All right, boys and girls, welcome back to Chapter 8 Review, Part 2 for Grade 4. We're going to get right into it. In Lesson 8.4, our essential question was, how can you multiply a fraction by a whole number to solve a problem? So now what we're going to do, boys and girls, is we're going to take a look at how we're going to solve problems by using what we have learned about multiplying fractions times whole numbers, unit fractions times whole numbers, and mixed numbers times whole numbers. So we'll look at a few different types of word problems. Once again, I want you to be looking at the words and I want you to be looking at the steps and thinking about what are the words asking me to do. Here's our first word problem. Lisa walks 6/10 of a mile every day. How far does Lisa walk in 5 days? Well, the first thing we know is Lisa walks 6/10 of a mile every day. What we want to find out is how far does she walk in 5 days? So we're going to take our whole number 5 for 5 days times the amount that she walks in 1 day, which would be 6/10, and we're going to go ahead and multiply that. All right, so we know that we can take our whole number and multiply it by our numerator. So 5 times 6 equals 30. And of course, our denominator always stays the same. So I can say that Lisa walks 30/10 of a mile in 5 days, or 30/10 miles in 5 days. But what does that 30/10 really mean? Let's take a look. I know that 30/10 is a fraction greater than 1 whole. It's an improper fraction. So we are going to need to rename 30/10. We know fractions do not like to be improper. So I'm going to take my numerator 30 and I'm going to divide it by our denominator of 10, and I'm going to think this through. There are 3 10s in 30. Okay, so I know that 30/10 equals 3. 3 what? Yes, 3 miles in 5 days is what Lisa actually walks. All right, that was pretty simple. That was pretty easy. Let's go ahead and try another one. All right, here's our second problem. Mrs. Kennedy always puts 1 1/2 teaspoons of honey in each cup of tea. Over the weekend, she drank 5 cups of tea. How much honey did she use in all? All right, let's take a look at what we know in this problem. Well, first of all, we know that she puts 1 1/2 cups of teaspoon of honey in each cup of tea that she drinks. Over the weekend, it was kind of cold. She drank 5 cups of tea. So what we want to do is we want to figure out how much honey did she use in all. So in this situation, we know that she drank 5 cups of tea. We know in each cup of tea, she puts 1 1/2 teaspoons of honey. We need to find out how much honey she's using. So let's work this out. 5 times 1 1/2 equals. Well, at this point, we're going to say 5 is our number of cups of tea. 1 1/2 is the number of teaspoons of honey per cup. So we're going to have to figure this out. I'm going to turn 1 1/2, my mixed number, into a fraction greater than 1 whole. How do I do that? You're right. I multiply my denominator times my whole number, and then I add my numerator. 2 times 1 is 2, plus 1 is 3. So 1 1/2 now becomes 3 halves times 5. Now I can go ahead and multiply. 5 times 3 equals 15 over 2. What does 15 halves really and truly mean? Well, let's take a look. I'm going to say how many 2's are in 15. You're right. I have to rename 15 halves, which is a fraction greater than 1 whole, It's an improper fraction. I know that there are 7 2s in 15 with 1/2 left over. So, how many teaspoons did Mrs. Kennedy use? She used 7 1/2 teaspoons. Mrs. Kennedy used 7 1/2 teaspoons of honey in 5 cups of tea. Good job. Let's try another one. All right, in this word problem, let's really take a look at the words and see what we're being asked to do. Miss Willowite made a macaroni salad. She used 1 1/8 cups of mayonnaise. She used 9 times as much macaroni. How many cups of macaroni were used in her salad? Let's go back and take a look. Here's what we know. Well, we know she's making a macaroni salad. She used 1 1/2 cups of mayonnaise. She used 9 times as much macaroni. My question is, how many cups of macaroni were used in her salad? All right, let's think about this. When I see the words times as much, I'm going to think of multiplication. So I think I'm going to take 1 1/8 cups of mayonnaise times 9 cups of macaroni, and I'm going to have to figure out what the answer here is. Let's take a look at the next page. 1 1/8 times 9 equals. Well, the first thing I'm going to say is I have a mixed number and I have a whole number. I think I'm going to take that mixed number and I'm going to have to convert that or rename that to a fraction greater than 1 whole. So I'll multiply 8 times 1, which is 8, plus 1, which is 9. 9/8 times the whole number 9, because that's how many times more cups of macaroni she used. So let's go ahead and multiply. 9 times 9 is 81 over 8. All right, she used 81/8 cups of macaroni. But that really doesn't make a lot of sense to me. I know that mathematically that's correct, but what's the answer? I think I'm going to have to take 81/8, which is a fraction greater than 1 whole. It's an improper fraction, and I'm going to need to rename that into a mixed number. So I know that there are 10/8 in 81 with 1/8 left over. So I guess the answer right here would be 10 1/8 cups of macaroni were used in Miss Willowite's salad. Miss Willowite's salad. Are you getting hungry yet? All right, let's go on to our next problem. All right, here's our next problem. Mrs. Brewer is making 3 batches of tortillas. She has to add 3/4 cups of water to the batches, 3/4 to each batch. Her measuring cup holds 1/4 cup. How many times will Mrs. Brewer have to measure 1/4 cup of water to have enough for all the tortillas? So let's go back and take a look at what we know. We know Mrs. Brewer is making 3 batches. She's making 3 batches of tortillas. We know that she needs to add 3/4 cups of water to each batch. Oh, here's the other complication. Her measuring cup only holds 1/4 cup. Measuring cup holds 1/4 of a cup. 3 very important pieces of information. Now, let's look at this question. The question is, how many times will Mrs. Brewer have to measure 1/4 cup of water to have enough for all tortillas? All right, so let's take a look at this one. First thing I know is that Mrs. Brewer wants to make 3 batches of tortillas. We know that in each batch she must have 3/4 of a cup of water per batch. Okay, so let's go ahead and start that. 3 batches times 3/4 of a cup. I'm going to go ahead and multiply 3 times 3, which is 9, and of course put it right over our denominator of 4. Now my question to you is, what do I do at this point? I know that I have a 1/4 cup measuring tool. So what I'm going to think about is I'm going to go ahead and take that fraction greater than 1 whole, and I'm going to rename it not as a proper fraction mixed number, but as an equation which shows a whole number times a unit fraction. My unit fraction is going to be 1/4. So 9/4 would be the same as some whole number times the unit fraction 1/4, because 1/4 is the measuring tool that I'm using. So I would go ahead and say that 9 times 1/4 is my equation showing a whole number times my unit fraction 1/4. So what does this mean? This means that Mrs. Brewer will need to measure 9 1/4 cups of water for all of her tortillas. 9 times 1/4 cup. Boys and girls, what we've tried to do is take a look at different types of word problems and look at the words being asked and looking at how we are solving them. There's one more. All right, in lesson 8.5, how can you use the strategy draw a diagram to solve comparison problems with fractions? Let's take a look. Rob is comparing shark lengths. He read that a sand shark is 4 1/2 feet long. A thresher shark is 3 times as long as that. We're going to use a bar model. We're going to answer the question, how long is a thresher shark? Before we get into the bar model, let's go back into our problem. Let's take a look. Well, the first thing we know is that a sand shark is 4 1/2 feet long, so I'm going to use that information right there. A thresher shark is 3 times as long as that. Wait a minute. As long as what? As that. Oh, that is the sand shark. So I need to make sure that I understand what the words are saying to me. Now, my question is, how long is a thresher shark? All right, let's take a look at our bar model. The first thing that we know is that a thresher shark is A thresher shark is 4 1/2 feet long. I know my thresher shark is 1, 2, 3 times as long. So my bar model must represent 1, 2, 3 boxes that are of equal length. Now, how do I set this up? Well, this must be the same as the box above it. This must be. So each one of these has to be equal. So what I'm trying to figure out is, what is the length of the thresher shark? So I'm going to say 4 1/2 feet times 3 equals the length of the thresher shark. Well, 4.5 times 3, I've got a mixed number times a whole number. So what I'm going to have to do is convert my mixed number into a fraction greater than 1 whole. I'm going to do that by multiplying my denominator times my, whole number. 2 times 4 is 8, plus 1 is 9. And of course my denominator stays the same. 9 times 3 equals 9 times 3 is 27 halves. Once again, I have a fraction greater than 1 whole. So I have to figure out what 27 halves in feet really truly means. So I'm going to go ahead and divide my numerator by my denominator, and I'm going to rename 27 halves into a mixed number. 27 halves is the same as 13 and 1 half. So I can go back and I can say that a thresher shark is 13 and 1 half feet long. Boy, that's pretty big. All right, boys and girls. In our reviews, we have gone through all of the essential questions. We have looked at how we're going to multiply fractions times whole numbers. Sometimes our fractions are unit fractions. Sometimes our fractions are standard fractions, where our numerator is something greater than the number 1. Sometimes we're dealing with mixed numbers. We're always multiplying times a whole number. What questions do you still have for us? We'll look forward to talking with you tomorrow in the review before the test. Good night.